This is the second video from our lesson on the application question from the Moore factor theorem, or factor theorem again, I can't remember the title, handout. So far what we've done is we identified that we were looking for the product of four people's ages. So we want to take our expression and break it down into four things being multiplied together. We found one of those things by trying to find something that gave us a remainder of 0 to get a factor. We've divided, and we stopped when we got this expression here. So our next step is going to be to take this bracket and see if we can factor it further. That's what the dotted line was for, was to separate the space, so that we are going to take this over to this side and see if we can factor it. So I have, I'm going to pick a different color. So we have now 5x cubed minus 4x squared minus 61x minus 12. So I notice that it has 4 terms. So when I have 4 terms, the first thing I do is check to see, is there a common factor? Unfortunately, 5 and 4 don't have anything in common other than a 1, and they don't all have an x, so there's no common factor. Then I would look to see if I could group in pairs. So if I were to group the first 2 together, I could take out an x squared, and I would get 5x minus 4. Am I going to get a 5x minus 4 out of this? Unfortunately not. 61 and 12 don't actually have anything in common. So factoring by grouping is not going to work here. So that means we would have to try to do factor theorem. Now we've already done factor theorem once. We used the numbers 5 and negative 12 to generate this list of numbers, and we're still using 5 and 12, so I think these list of numbers still apply. I already got one that was just 1 that worked, so I'm going to try to see if we can find another number that would make this factor. So back to my calculator, we're going to see if we can come up with another number. Now sometimes you can check this number a second time, so I might do that because you never know, maybe 2 of them are twins. So I'm going to try 1 again in my new equation, not the old one, but the new one. So I have 5 times 1 to the power of 3 minus 4 times 1 to the power of 2 minus 6 times 1 minus 12, and I got negative 17. So clearly that didn't work. I could try negative 1. That 61, though, to me is kind of big. Well, we'll do it anyways. So 5 times negative, oops, I need to be able to see my equation. 5 times negative 1 squared, nope, cubed, minus 4 times negative 1 squared minus 61 times negative, ooh, no. So 61 times negative 1 minus 12. Nope, that didn't work either. I didn't think it was going to. Okay, up next, I still have the same list. I could try some of the fractions. I could try a different number. I could see if I feel, lucky about one of them. I think I might try 2 next. Okay, so 5 times 2 to the power of 3 minus 4 times 2 to the power of 2 minus 61 times 2 minus 12. Nope, that didn't work. I'm going to try negative 2. Sometimes you have to go through quite a few before you find one that works. So 5 times negative 2 to the power of 3 minus 4 times negative 2 squared minus 61 times negative 2 minus 12. Well, that didn't work either. Alrighty, maybe I'm going to try 3. Alright, so 5 times 3 to the power of 3 minus 4 times 3 to the power of 2 minus 61 times 3 to the power of 3. No, I have to start over again. 5 times 3 to the power of 3 minus 4 times 3 to the power of 2 minus 61 times 3 minus 12. Well, that didn't work. All right, I'm going to try negative. Okay, so 5 times negative 3 to the power of 3 minus 4 times negative 3 squared minus 61 times negative 3 minus 12. Woohoo! I finally got one that gave me a 0. Yay! Sometimes it takes a while to find a number. Sometimes you get lucky and you find one right away. So there should be 2 others in there. Maybe you tried some and found one faster than I did, but unfortunately that was as quick as I got. So that means x is going to equal negative 3. So x plus 3 is my factor. So that tells me here that one of these brackets is x plus 3. Okay, so my expression so far is this. So now I know it's x minus 1 times x plus 3 times something. We're going to have to figure out what that something is, right? So I know that this part here is x plus 3 times something. So I've got the x plus 3. We are now going to do some division. So how many times does x plus 3 go into 5x cubed minus 4x squared minus 61x minus 12? Okay, how do I turn an x into a 5x cubed? I multiply by 5x squared. So 5x squared times x is 5x cubed. 5x squared times 3 is 15x squared. And then we subtract. 5 minus 5 is 0. Negative 4 minus 15 is negative 19x squared. I have minus 61x minus 12. How do I turn an x into a negative 19x squared? I multiply by negative 19 and x to get negative 19x squared. And then negative 19 times 3 is negative 57x. I subtract. Negative 19 minus negative 19 is 0. Negative 61 minus 57 is the same thing as negative 61 plus 57, which would be negative 4x. Negative 12 take away nothing is negative 12. Okay, how do I turn an x into a negative 4x? We multiply by negative 4, so I get negative 4x, and then 3 times negative 4 is negative 12. Negative 4 minus negative 4 is 0. Negative 12 minus negative 12 is 0, which is good. That means it went in evenly, which it's supposed to. So that means that the remainder of that bracket is 5x squared minus 19x minus 4. So this part here is 5x squared minus 19x minus 4. Right? The 5x cubed minus 4x squared minus 61x minus 12 is x plus 3 times 5x squared minus 19x minus 4. And then we figured out that x minus 1 from the original. So we've now cracked the code on 2 of them. We have 2 more brackets to figure out. In order to do that, I am just going to do some regular factoring. Just trying to find a different color. It's stuck in the container here. Okay, so I need to take 5x squared minus 19x minus 4 and see if that will factor. So I have some space over here. That's where I'm going to do it. So I have 5x squared minus 19x minus 4. It has 3 terms, follows the pattern x squared, x, and a number. So I should be able to use some decomposition. It does not have a common factor, and I can't use the shortcut because there's a 5 in front. So I'm looking for 2 numbers that add to negative 19 and multiply to the same as 5 and negative 4, which is negative 20. Okay, things that would multiply to 20 would be 1 and 20. Can I make a negative 19 out of that? Well, if I did negative 20 and positive 1, I could add them to get negative 19. Would 1 times negative 20 equal negative 20? Yes, it would. So that means this is 5x squared. I think the 20 would go nicely with that, so I'm going to do minus 20x and then plus 1x minus 4. First pair, they both divide by 5 and x. And if I do 5x squared divided by 5x, I get x. Negative 20x divided by 5x is negative 4. From the second pair, they don't really have anything in common, so I'm going to divide by just 1. That's what I'm going to factor out. And since it's a plus here, I'm going to do plus 1. 1x divided by 1 is just 1x, or x. Negative 4 divided by 1 is just negative 4. These two brackets are the same. That means this is x minus 4, and then 5x plus 1. Okay, so that means my last two brackets are x minus 4 and 5x plus 1. So that means this expression is x minus 1 times x plus 3 times x minus 4 times 5x plus 1. Whew, that means we have finally factored it into 4 brackets, which is what our goal was. Our goal was to figure out the 4 things that we were multiplying here in order to make this happen. So one of these is Ella, one of them is Franklin, one of them is Greg, and one of them is Hannah. The clues that they gave me is that Ella is the oldest, and then Franklin, and then Greg, and then Hannah would be the youngest. So I'm supposed to assign one of these to each person. So I'm going to just split up. We have Ella, I have Franklin, I have Greg, and we have Hannah. So the oldest should be the expression that would give me the largest number. The youngest should be the expression that would give me the smallest number. And if you have trouble figuring it out, you could just mentally pick a number, right? Like 10 or 20 or 100 or something. Try subbing it into each one and see which one's going to give me the largest number and which one is going to give me the smallest number. So I think the smallest number is going to come from the x minus 4 because we are subtracting the most from that one. So I'm thinking that would be Hannah. And then Greg, this is the other one with subtraction, but we're not subtracting as much. So I'm thinking that one is probably Greg. And if I tried numbers, like if I did 20, 20 minus 4 is 16, 20 minus 1 is 19. 16 is smaller than 19, right? Let's stick with that 20. 20 plus 3 is 23. 5 times 20 plus 1 is 101. So I don't think Ella is actually 101. I'm just trying to see which one would give me the largest number and which one would give me the smallest number. So I think the x plus 3, that gave me 23 when I tried putting 20 in. And then this one gave me 101. So I think she is 5x plus 1. Franklin is x plus 3. Greg is x minus 1. And Hannah is x minus 4. So you should write a final answer. But I'm out of space and I'm running out of time on this video. So I think I'm just going to leave it at that. But normally I would say therefore Ella is, Franklin is, Greg is, Hannah is. Okay? So you can join me in the last part, hopefully, of this video to do part B of this question.